In this video, we're going to learn how to multiply polynomials. Let's start with the following example. In this example, we will need to multiply monomial 2x squared by binomial 4x to the third power plus x. So to multiply monomial by any kind of polynomial, so here I have binomial 2 terms, right? But I can have 3 terms, 4 terms, or as many as I want. We will always apply the following rule. We'll use distributive property, which is taking monomial that's standing in front of the expression of the parentheses and then multiplying it by every term inside the parentheses. So I'm going to write it out for this first example, but next time we'll do it a little bit quicker. So what it means is that first I have to take 2x squared and multiply it by 4x cubed, and then I have to add the product of 2x squared. Again, I'm taking 2x squared, but this time I'm multiplying it by x times x, like that. And let's perform each multiplication. So 2x squared times 4x cubed. Remember, numbers have to be multiplied together and then variables have to be multiplied together. So when I multiply numbers, it's 2 times 4, which is 8. And when I multiply same variables, I have to add their powers. So add their powers. So power of x is going to be 2 plus 3, which is 5. And next, I'll have to multiply again number by number, but I don't have 2 numbers here, I only have 1, so it's just going to stay as 2. And then once I multiply variables, same thing, I have to add their powers. But what is the power of that second x? Since it's not visible, it's power 1. So when I add the powers 2 plus 1, I'll get x to the third power. And that's going to be the answer. Let's try one more example. In that example, once again, we're going to multiply monomial, let's say negative 7m to the second power by, let's say, trinomial this time. 4m to the third power minus 2m squared minus 5. Let's try. Same idea here. We're going to use the distributive property. So we're going to take negative 7m squared and we'll multiply it by every single term inside the parentheses. This time, let's skip that middle step where we write out the multiplication, but let's just say it out loud. So for example, I have to multiply negative 7m squared by 4m cubed. Remember, I have to multiply numbers first, and here I notice how in this example I have both positive and negative numbers, so I have to incorporate all that in multiplication. So it's negative 7 multiplied by positive 4. Negative times positive gives me negative, and then 7 times 4, it's 28, negative 28. Number times a number. And now multiplying 2 variables. As I am multiplying variables, same variables, I have to add their powers. So what's going to be the power of m? Well, it's 2 plus 3, which is 5. Okay, that's the first term. Next term. To obtain next term, I'm going to take negative 7m squared again. But this time I will be multiplying by negative 2m squared. So let's start with numbers. Negative 7, I am multiplying by negative 2. Well, negative multiplied by negative gives me a positive result. And for this reason, I'm going to be putting plus. Remember, all terms in my answer should be separated by minuses and pluses. Well, here's the plus from multiplying negative by negative. Negative 7 times negative 2 is positive 4. It's positive 14, sorry. So that's going to be plus 14. And what's the power of m? It's 2 plus 2, so it's 4. And finally, the last product. So it's negative 7m squared times negative 5. So in this case, I only have a number. Well, that number has to be multiplied with a number with a coefficient from my monomial here. So it's negative 7 multiplied by negative 5. Once again, it's negative times negative, so it's positive plus 35. And since I didn't have anything to multiply by m squared, it means that m will stay with its original power. Power will not change, so it's just m squared. And that will be the result. Now, these two examples were for multiplying monomial by some kind of polynomial, right? Using distributive property. What if we try to multiply two binomials? So let me write down next example. So let's start with something not too hard. So it's 4x plus 2, that's the first binomial, and I'm multiplying it, and that's why I'm gluing together those two sets of parentheses, by 5x minus 6. Notice that there is nothing in between those parentheses, so it means that I am multiplying. If I had plus or minus in between, then I would have to just simply combine like terms, right? Well, clear parentheses and combine like terms. So try not to confuse multiplication with other operations. Nothing in between, glued together, multiply. How are we going to multiply two binomials? Well, we're still going to be applying that distributive property, but in a special way, and this is how it's going to go. We're going to start with the very first term in the first expression, and we're going to apply distributive property for the term. What I mean is that we're going to take 4x and we're going to multiply it by everything inside the second parenthesis. Okay? Now, once we're done with that, we're going to move to the next term, which is 2. And we're going to apply distributive property to the term as well. So in other words, we're going to take 2, positive 2, and multiply it by everything inside the second set of parentheses. Let me just make a note here that if that's not your very first experience multiplying expressions like that, you might be familiar with other methods like foiling, right? You can use what we call FOIL to multiply those out, or there's also a box method. So all those are good, and essentially they're following exactly the same idea. But as you can see, I'm just using the distributive property and those arrows to help me to multiply out. Let's try. Let's follow the red arrows first. So for x, I have to multiply by 5x. So number by number, variable by variable. So 4 times 5, that's 20. And then x times x, that's going to be x squared, right? So it's power 1 plus power 1, that's going to be power 2. Next, 4x times negative 6. So number 4, positive 4, I have to multiply by negative 6. Positive times negative, that's negative 24. And then x, I have nothing to multiply by, so it just stays as x. So we got that from distributing 4x. And now we have to move to 2 and distribute that as well and continue writing the results. So 2 times positive 5x. 2 times 5 is 10. Since it's positive, so it's plus 10. And then x. I didn't have anything to multiply x by in this case, right? And then finally 2, positive 2 times negative 6. That's negative 12. When we multiplied, we want to check if we can simplify this expression. And the way we can simplify it is by combining like terms. Do we have any like terms here? Let me remind you that like terms are terms that contain same variables and same exponents or powers. Well, yeah, looks like we have like terms here. We have two terms here right in the middle. I'm going to underline them. That have same variable, which is x, and those x's raised to the same power, which is 1. It means that we can combine them. Now, I will bring down the first term. I'm not going to be able to combine with anything, so I'm just copying it down. And now let's combine those two. So to combine like terms, we only need to combine the coefficients. So add, subtract coefficients. So it's negative 24 plus 10. Negative 24 plus 10, that's negative 14. And then we simply rewrite that variable, so we don't adjust the variable, right? So we don't do anything with the power. We simply rewrite it. So after combining those two terms, we got negative 14x, and then we bring down minus 12. That's the answer. We're going to try one more example. In this example, we're going to be multiplying negative 2y plus 5 by negative 2y minus 5. Now, I suggest you pause the video and try that example on your own using the previous examples or steps from the previous examples, and then you can compare your answer. But this is how you have to multiply. So these are two binomials, and we're going to use this distributive property when we take the first term in the first expression and multiply it by everything inside the second expression. Once we're done with that, we're going to move to the next term and repeat the process. We're going to take that second term and multiply by everything inside the second parenthesis. By the way, I strongly encourage you to show those arrows because they help you to stay on track and they help you not to lose any terms. So do those arrows, they help you, trust me. So let's try. Negative 2y times negative 2y. Negative 2 times negative 2, that's positive 4. Y times y, that's y squared. Now, negative 2y times negative 5, it's negative 2 times negative 5 plus 10, and then y. That's the first two terms. Now the second two steps, it's positive 5 times negative 2y. It's negative 10y, right? 5 times negative 2, negative 10y. And then finally, positive 5 times negative 5, minus 25. Okay? And after that, I have to check for like terms. And I can see that here in the middle, I have 10y and negative 10y, or 10y minus 10y. These are opposites. See how they have same variables, well, they're like terms, so they have same variables raised to same powers, but then the coefficients are opposites. So that means that those two cancel each other. And I am left with 4y squared minus 25. Okay? And our last example will be the following. So let's try, if you got this idea, how you multiply out polynomials this way, well, in this case, they're binomials, then it doesn't really matter if we increase the number of terms. So that's what we're going to try next. So we're going to do x plus 3 times 4x squared minus 5x plus 1. So this time I am multiplying binomial by trinomial. But again, with this method, I don't care how long each expression is, because what I'll do, I'll just continue with the pattern. I'm going to start within the first expression with the first term. And that term has to be distributed. It means that it has to be multiplied by every single term inside the second parenthesis. So I don't care how many terms I have there. If I have 5, I'll just multiply all 5 of them, right? If I have 10, I'll multiply all 10 of them. Well, this time I have only 3, but I'll multiply x by each term, so I'll have 3 arrows, like that. Once I'm done with that multiplication, then I'm going to move on to the next term, which is 3, and distribute it the same way. So multiply it by everything inside the second set of parentheses. And guess what? Well, if I had more terms here, I would continue. I would move to the next term and distribute it again, and to the next term and distribute it again, and so on and so forth. It's just going to take me longer, but No, I don't really care what kind of polynomials I'm multiplying out. But that's what we have in this example, so let's finish it. So x times 4x squared. Now, as far as the numbers, I only have 4 here, it stays as 4. What's going to be the power of x? X times x squared. I'll combine powers, I'll add powers, so it's going to be x to the third power. Next, x times negative 5x. Once again, constant stays, negative 5, but x becomes x squared. And then finally, x times 1. Well, it's just x, right? 1x or just x. Anything multiplied by 1 stays the same. Now, let me just fix that. And then we're going to move on to multiplying 3. So let's continue. Positive 3 times positive 4x squared. Here I will be multiplying just numbers. 3 times 4, it's 12, so it's plus 12. X stays with its original power, x squared. Next, positive 3 times negative 5, it's negative 15, and then just bring down x. And then finally, positive 3 times positive 1, that's 3, like that. Okay, so here, since I had 6 arrows, I should end up with 6 terms, and that's exactly how many I have. So the last step would be to combine like terms. Let's start searching for like terms and begin with the highest power, with the highest degree. So 3 is the highest degree. Looks like I don't have anything to combine with 4x cubed, so I'll just bring that down, 4x cubed. Next I have power 2, and I do have a few terms with the second power, that one and that one. So when we combine like terms, remember that we don't mess with the powers, right? We're going to keep it as x squared. We only need to combine the coefficients. Negative 5 plus 12. That is positive 7. So plus 7x squared. Next, I'm moving on to x. It's x and negative 15x. Same thing. I'm not doing anything with the variable itself, but I need to combine the coefficients. What is the coefficient of x? It's 1. So it's going to be 1 minus 15. 1 minus 15 is negative 14. Negative 14, and I just rewrite x. And then I have this constant at the end. I have nothing to combine with, so I'll just copy it down. Plus 3. And that's going to be the answer. So that's how you multiply polynomials.